Hello, this is Carlos Segreja, and this is a C++ project. What it does is take an infix and I'll calculate and output a postfix. That's all it does. I'm not sure exactly what this is for, but that's what this program does. And the postfix, if I had to guess, it reminds me of like registers, something easy for the ALU, arithmetic logic unit or something. But how it works is so let me go over these. Alright, so we have A plus B minus C, and then so what happens is A and B gets added together, and then that gets, C gets subtracted from that. So yeah, that's how it works. So yeah, C will subtract these two, but that's the precedence. The way, how it works. This would get added together, and this would then the subtraction would happen. So that's how that is. The multiplication, obviously, multiplication gets done first. So in this case, you have the C. So once it sees this multiplication, it's going to take this and multiply by this, and then it's gonna, you're gonna have two variables now. So and then it's gonna or just add A on there, I guess. Just add A to that. So something like that. A times B plus C. So once it gets over here, multiply the B and the A, and then we have a C, and then plus, so it would be C plus this product, and yeah, that's how it works. It's got parentheses, so it takes parentheses. So parentheses have precedence. So in this case, this would the addition would get done first, and then the multiplication. So C times this. So as we have the A and B does get added first, and then C, multiply that, C times this sum. So yeah, so it does the parentheses as well. Division, basically the division is just like the multiplication, nothing big there, and that's it. That's what it does. So if you're interested in the code, I'll take a quick look at the code. It's been a long time since I've looked at this code. I'm just going through my projects now. It's 2016, and I've done these in like 2014. That's when I did data structures and algorithms. So yeah, let's look at it. It looks like use a stack. So we got the initial postfix variable, initial postfix to an empty expression, and also initialize the stack. Okay, so we have this postfix equals nothing. We have this stack of strings, and we have string sim, which is empty. Length. Alright, so this is the infix. That's going to be converted to postfix, and that's this convert to postfix method. So get the next symbol, sim, from infix. So this is going to go through the entire infix, and so get the sim, first sim. So is it alpha? So alpha, in this case we're using algebra, so A plus B. So if it's alpha, then it's kind of like a number, or else either that, or it's going to be a parenthesis, or it's going to be an operator. So we have if is alpha, so we have this condition, postfix, append the sim. Okay, then we have an else if it's not alpha, so is it a parenthesis? So we want to check for that. It looks like in this case it can be either parenthesis, and they both handle here, I guess. So infix equals this parenthesis, push it on to the stack, and then so if the symbol is this parenthesis, which looks like it will be the end of parentheses, so at this point It's probably gonna evaluate, or so bool done, done, while done is false, so just keep going. So we got sim equals stack pop, basically with the last symbol that was put on the stack, so still the value on the stack, and then we'll look at that, and if it's this, then end of parentheses, discard the parentheses because we don't need that, and exit the while loop because we're done. Okay, so basically that's all it does, and pop, and then if we're all done, if it was a parenthesis, then that's it, we're done, and we can exit this while loop. Otherwise, what it does is append the sim, so append the symbol to the postfix, and discard the symbol from the stack. So yeah, so all it does, and then we have this condition here, if equals this, which I'm not really sure what this means. My guess would be maybe it's the end, but yeah, I'm not sure. That's obviously not algebraic or anything. So after processing infix, some operators might be left in the stack. Pop and append to postfix everything from the stack. So okay, so alright, so this must mean the end of the infix, apparently, and then just wants to check if there's any operators left on the stack to so it's just gonna go here while stack, empty the stack. So stack, take the last symbol that was put on the stack, basically, because that's how stacks work. Put it on, pop it off. So put it on, or stack top, get the item from the stack, and then append it, and then pop. So yeah. And that would just loop, straightforward really. If sim is an operator, so this is how, if operator, so it cannot be alpha, and that's how the operators are handled. So pop and append all operators from the stack to postfix that are above the most recent left parentheses and have precedence greater than or equal to the symbol. So while stack cannot be empty, if, I like the comments. I've always been a little comment crazy, happy, whatever. So if precedence, stack dot top, and pass these two, pass the stack top operator and the sim, and so yeah, and it's going to check the precedence. So yeah, and sim was we right here, so that's what sim is, and so yeah, we want to get the stack top and match that with the sim that we're right now evaluating. So postfix append stack top. So if this precedence, so that's obviously a method. So, and all that method does is return precedence. So I'm guessing this will turn true or false if one has precedence, and else break. So okay, so we'll go in here, and then the postfix append the stack top, and then pop. Otherwise break. So probably means don't append it, keep it stored. So if this returns false, if it doesn't have precedence, then keep it stored. So if it does have precedence, then output it. Basically that what that code pairs to do. And alright, so that's the end. Push sim onto the stack. So so stack push sim. Okay. Okay, so break out of this while and push the stem on the stack. Okay, so yeah, so if it doesn't have precedence, it looks like it's pushed to the stack. If it does, it gets appended and popped. So makes sense. So precedence takes this one and this one. The two operators, and what it does is compare if operator 1 equals either one of these, then has this precedence, and that looks like what it does. Just basically looks at operator 1, and if it has precedence, it will give it a 2 or 1. So a 2 if it's multiplication of the division, a 1 is a precedence if it's a plus or a minus, and if it has parentheses, it has a 0. So, and then it checks the, so if else, and then we have check the so the second operator 2 is also checked basically for precedence, but it doesn't check for the parenthesis. So yeah, and then just returns if the precedence of, if the first one is greater or equal to precedence of the second one, and that will equal either true or false. So precedence 1 is the operator 1, and precedence 2 is the operator 2, and so if the first one is greater or equal to the second one, and that's it. So that's really all there is to this function. So if we go back here, it takes the stack top and passes the, so if this stack top is greater or equal to the symbol is what it returns, and yeah, so that's it. So if it's greater or equal to the symbol, then we want the to append the stack top, otherwise, and pop. Otherwise, we're going to push the symbol on to the stack, or rather, this will get done. This will get done anyways. So once it's not, it just goes to break and then appends the symbol. So yeah, that's how that works. So yeah, that symbol is going to be handled. Basically, that's how this whole all the iterations of this whole for loop work, and that's the whole process there. So that's how it's done. And then there's that's pretty much it. That's the function that I wrote. So you know, the other stuff, just, you know, print the screen and all of that stuff. So anyways, hope you enjoyed. Thanks for watching.